So, again, yesterday we talked about local or relative extrema. Today we're going to address absolute extrema. And the clue here for the difference between which one you're supposed to find, because sometimes you have to kind of read into the problem. With the relative extrema problem, you're going to be usually given no interval to analyze. Okay? So your function's just going to go, right? There's no absolute extrema on that. Versus absolute, where we're going to define an interval for the function. And I would say it's just a piece of the function. So that has an absolute min or max, right? Here and here. Okay. So you're going to restrict this on some interval, and it has to be a closed interval from A to B. Okay. That's your biggest clue when you're calculating, just mathematically calculating these problems. Okay, word problems, you kind of have to read into them a little bit, and we'll train you up on recognizing that. Okay. Might be something like, at what time was there a maximum amount of gravel at the processing plant? Now, is there an interval defined there? No, but is it implied? Yeah. Because the maximum could be at the start or the end of the day, right? Or it could be in the middle. So, start or the end. It's the beginning and the end for you now, Montaigne. So, we're going to address this today. It's a very similar method. There's just one change at the end. Okay? And I'll show you some different examples, let's do this one. Find the extreme values of x equals -8 natural log x on 1/4. Okay. So you see the interval. You know this is an absolute min-max problem, right? So we've defined that. Recognize. You better recognize.
Oh, it's not because Mark has expert. I was so confused.
Sometimes don't know what to say. All right, so how did we find extreme value yesterday? Yeah, calculate derivative equals 0. Same process here, okay? Thankfully, right? So what is the derivative?
2x minus, I don't remember how to do it.
It's 1 over something.
1 over x.
1 over x, yeah, so we have 8 over x, correct?
Because the
Natural log's derivative is 1 over x. So, and just leave the 8 because it's the constant attached. Oh my goodness. Why did we do a problem just like this in pre-calculus this morning? Almost exactly. Yeah, it is weird. I said, you better be ready for calculus. Here's a problem you'll see. Boom, baby. How do I solve that? It? It's a bad word in here. I'm going to write you up, Hartzell.
subtract 2x or add 8x.
Yeah. Add 8 over x to both sides. Now what? We have to still get the x's together, so we need to multiply by x to get rid of it over here, right? Yeah, now we have 2x squared equals 8.
Okay.
So x is
No, oh yeah.
2 or,
Plus or minus
thank
2.
you for listening to your training.
Because when you divide by the value and x squared equals 4, we take square root 4 plus or minus 2. That was not my question.
What's your question?
How did you get rid of that?
If you, this is division. If I multiply by an x, what do division and multiplication do to each other? Bye-bye. X over x is 1. I don't. Okay. Now, at this point, yesterday we did a sign analysis, correct?
Okay.
This is where the change happens. With absolute extrema, we have to use what's called the candidates test. So yesterday it was the first derivative test, right? This is called the candidates test. What are our candidates for the min and max?
Plus or minus 2, they have to be between 1 and 4.
1
1 and 4.
and 2 and 4. Is negative 2 an option?
No.
No, it's not, because it's not in the interval. Right? Negative 2, we don't have to worry about it, because it's not in this interval. Right? So we need the endpoints, 1 and 4, and the critical value that's in there. Okay.
So we're trying to
Endpoints, critical point. Okay. Now, what do we plug them into?
derivative?
No.
No.
That's where people make a
Oh.
mistake. If I want to figure out what the highs and lows are on a graph,
Oh, you plug
All
it into the
position,
original.
so it'd be the original.
I have to plug it into f of x. Okay. Number one mistake. So local extrema analysis, derivative, absolute function,
What in the world
Yeah.
does CP mean?
critical point. All right, so what is f at 1? 1 squared minus 8 ln 1, which is 1. What's ln 1?
0.
Yeah, it is. This one would be 4 minus 8 ln 2.
Negative 1.545.
You calculated that up, I assume? Okay. And this would be 16 minus 8 ln 4. I'm guessing that's going to be bigger than 1.
11.184.
Okay, so you're good on that? All right, so what's my absolute maximum?
4.
No.
It's 2 because that was the critical point within the interval.
F has an absolute max
At 2.
of 11.184 at
X equals 4.
x equals 4. Okay, so this is the value. This is the location of that value. Okay. F has an absolute, that's max, min of
Negative 1.545.
lowest number, negative 1.545 at x equals 2. Okay. Do I need to say why?
No.
No, I don't. It's right there.
The math says so.
Yes. Whereas with the local, you have to explain that. Absolutes, right there. Just it will it will probably say something like, find the extreme values of f of x, justify your answer. Guess what? You just did it. Okay? It's very neat and clean. You just got to keep the local versus absolute separate in your brain. Okay. Would you like me to show you a trig function? Usually, or an exponent that becomes negative?
Exponent.
Which one's worse?
So what? Probably both.
Exponent.
Okay. Let's try this one. So again, find the extreme values. Yep. What's the derivative?
X minus 1 to the negative 1.
Yeah. Okay. Again, negative exponent. Do I rewrite it?
Yeah.
Yeah, I do.
So it's
1 over
2 over
x minus 1 to the negative 1/3.
positive now.
So what happened to the 3?
I don't know what you're talking about. Okay. Good. You're good on rewriting that. It's a negative exponent, so this comes to the denominator. Can that ever equal 0?
No. No.
Why not?
Because the top will never
Yeah,
be
this
0.
will never be 0, right? Nope.
I get it now.
Okay, but is there a spot where that is not continuous?
Yeah.
Not differentiable
At x equals 1.
at x equals 1, because it gives us a denominator of 0. So you're looking for denominators and numerators of 0 here, right? So this would be considered a critical point that we need to consider, right? Because the function changes direction there. So my x's are, for my candidates test,
I'm confused what happened to your negative when you went from fx to f prime x.
what negative?
The 1 minus.
Minus, it's right there.
What? You can't just flip it.
I didn't flip it. It's,
You can't just stick it in front of the 2/3 now.
it was already in front of this. The 2/3 just came down to.
Then what happened to the 1?
The 1
Oh, it
with-
was a constant.
That's math murder, man.
Yeah.
What are my candidates?
-1, 1,
And which function do I use?
Original.
F of x. Right?
Right.
So what's f at -1? -2 to the 2/3.
Negative 1.5 per 2.
Oh.
Sorry, I did. Oh, no, that's, sorry. I'm messing you up. It is negative 1.
Little children.
Yeah, that's what I was saying to myself.
Okay, what is the answer to f at -1?
So negative 2.5800.
Did we ever find the critical point?
F at 1? is 1.
That just makes it not
At that 2 is 0. Where's my minimum? Thank you for looking. Where's my maximum? There you go.
Wait, your math is confusing me. How come 1 is a critical point?
Because this is not differentiable at 1. It creates a denominator of 0.
Yeah, I thought we decided that's not a critical point.
No. It's a function, it's a place where you have to analyze the function for min and max. Because this function is one of those line birds.
But didn't you try to do that earlier?
This cusp is where there's not differentiable on the cusp, right? But it can be a min or a max. So we have to analyze the function at that point. Okay? Right, so again, derivative, set it equal to 0, do the candidates test.
Yes.
So when they're undefined, that means that's critical.
It's, yeah.
Because when we did that one, we did that, and it was where there was a vertical asymptote, but you didn't know what was on that side of it. Like, had like a difference.
Yeah, but that's a discontinuity in the function. This function is continuous here. So it can be a min or a max, but the derivative does not exist. It's different. Okay. Good? Let's take a look at an AP problem.
Oh, fun. Starting early.
Okay, so something like this was on your test. Graph of f prime is given to you, right? So you're doing these free responses. What do? I circle this. I make sure I know it's f prime. Okay? All right. Look at A. Find all x coordinates at which f has a relative maximum. Give a reason for your answer. Okay. When does f have a relative max?
-1, 3.
When the derivative equals 0 and the derivative goes from positive to negative, right?
Yeah, that's right.
Where does that happen here?
Bigger 1, 3.
-1, 1,
No.
Not 1, just
The derivative has a 0 here,
0 has.
and here, and here. You're given the derivative. This is why I brought this one up, right? You're trying to think that this is the original function. It is not.
yeah.
This is the derivative. So are there points where the derivative goes from positive to negative?
Yeah.
Where?
1.
No.
1.
That's where the derivative has a horizontal tangent line.
-2.
1, no, negative values. There's nothing there. The derivative does not change sign. The derivative goes from positive to negative at x equals -2.
No.
These values are not the original function.
Yeah.
You are trying to treat this like the original function, saying that there's a horizontal tangent line here and there's a dip.
So at
No.
1,
No.
at 1, as it comes from the left, it's going from really negative to less negative, and then it gets to 1, goes to 0, and then just goes more negative. Yeah, that's how that works.
Yeah, so think y values. What's positive up here, right? Negative down here? Positive to negative, the derivative. There is a maximum value of f right there. Okay? So this is a more graphical approach than algebraic that I've shown you, right? Kind of funky to think through it that way. But that's why we circle that this is the derivative. The derivative goes from positive to negative. Okay. That means the original function would be shaped like this somewhere. Okay. That was a relative max or min problem. right?
What would the reason for the answer be?
Where is F decreasing? Where the derivative is negative, right? So from -2 all the way to 4. The derivative is negative, F is decreasing. F is increasing here because the derivative is positive. Okay? All right, let's look at one other one. Okay, here's a word problem. The rate at which rainwater flows into a drain pipe, so exciting, is modeled by the function r, where r of t is 20 sine t squared over 35 cubic feet per hour. T is measured in hours from 0 to 8.
Oh.
The pipe is partially blocked, allowing water to drain out the other end at a rate modeled by d of t, cubic feet per hour, for 0 to 8. There are 30 cubic feet of water in the pipe at time 0. Okay. Look at, so some of this we haven't touched yet, they're integrals. Is the amount of water in the pipe increasing or decreasing at time 3? That's derivative, plug 3 in, right? Is this a position function or a derivative? It's a rate, so it's a derivative. You're given the derivative here. You have to recognize that as the derivative. If you plug 3 in, if it's positive, increasing, negative, decreasing. Right? Okay. Part C. At what time from 0 to 8 is the amount of water in the pipe at a minimum? Local or absolute?
Absolute.
Why?
Because the interval is 0 to 8.
Yeah, they do give you an interval here. So this is an absolute.
At what time t without the interval would be a local? We didn't write that in a local format.
At what time is there a maximum amount of water in the pipe? Could be,
Okay.
but you're still, they're going to ask you, is the amount of, when is the maximum? They gave you the boundaries here for some reason, but sometimes they won't give you the boundaries, and they'll still ask you, when was the water at a maximum amount in the pipe? You still have to consider that that's an absolute max problem. Okay, so this would be derivative equals 0. And you have a calculator on this, so all you do is look at the graph and find the 0.
And then make sure it's within the FD.
And then use your interval for the candidates test. Okay. We'll get more deep into that, but I just wanted to give you a comparison of the two.
Then, if we did the candidate test, what would be the actual
Well,
equation? Because
that's where we haven't got to yet.
Is that the antiderivative?
Yeah, it's an antiderivative. Because you have to figure out the amount. You have to go from the rate equation to the amount. So, yep. Okay, I'm done. Concern yourselves with being able to calculate these right now, mathematically. I just wanted to show you those AP problems. Okay, so you have I've discussed, because I have more to do tonight.
You know, I have discussed for that, but I discussed something I don't think we should. We talked about
What about it? Is it so like the way we want it?
we have stuff to do about
Okay,
yeah,
there you go.
News flash, have you heard that? Yeah, not necessarily to you, about you.
Today's Thursday, right?
Yeah.
And then chapter 4.
Yeah, please.
Okay, so we I can give you the weekend if you want.
Please.
Tuesday?
I would not want to miss some school.
Because I'm changing my schedule up here. I think what I'm doing to rework is gonna work better.